Okay, so this is your Voltable about complex numbers. I want you to be able to use this, so carefully follow along with me. Okay, so you're going to open it up, and this is going to be your first flap. So just what is complex number? A complex number is a number that can be written in form. Okay, so this is the different forms that you could see a complex number. So you can see it as a plus b I. This right here is real, and this right here is imaginary. Okay, so this is an imaginary number. So what I is equal to the square root of negative 1. So if you have some number that's a negative underneath your radical, that is when I would come in and an imaginary number would be brought in, and that's when you would use that notation of I. Also, I want you to think about if you see I squared, which is just this negative 1 squared, it is going to be equal to negative 1. Okay, so now I want us to talk about how to add and subtract complex numbers. When you add and subtract complex numbers, you are going to combine the real parts and then imaginary parts separately. So you're going to combine the real parts and the imaginary parts separately. That's very important. Okay, so here is an example of one. Let's do this. 5 plus 7i plus a negative 2 plus 6i. Now you would combine, because you're adding, you can just move them around to where you are combining the real parts and then the imaginary parts. So you can say 5 plus a negative 2 plus 7i plus 6i. Okay, so whenever you do that, you've got 5 minus 2, which is 3. And then when you have that, you've got 7i plus 6i, which is 13i. Okay, and that's how you would add and subtract complex numbers. Now, multiplying is a little bit different, so I want to go over this one too. When you are multiplying, I is a factor that is treated as 1. Okay, so if you have this example, 5i times 4i, that would equal 5 times I times 4 times I. Okay, so from here you would be able to say 5 times 4 and then I times I. So then you would have 20 I squared. Okay, and then as up here as we defined, I squared equals negative 1. So this equals 20 times negative 1, and that equals negative 20. Okay. Now you might think it's really strange for you to, if you start with two i's, you're probably going to end up with a real number. I know that's really strange to think about, but I want to now go into using polynomial multiplication. So let's use polynomial multiplication. I can spell. Rules to multiply. So what you're going to do in this example is you're going to multiply two binomials that have a complex number inside. So you're going to have 2 plus 3i times 4 plus 5i. Okay, so now you're just going to use the same rules as polynomial multiplication. So you're going to use your distributive property. So you're going to say 2 times 4 is 8. And then you're going to have 2 times 5i, so 10i. And then you're going to have 3i times 4, you're going to have 10i. And then you're going to have 3i times 5i, which is 15i squared. Okay. And then you're going to be able to combine like terms just like you would if these were your x variable, but they're not a variable, it's an imaginary number. So you kind of treat it that way, but you know that that is an imaginary number, okay? You'll be left with 8 plus 22i plus, and you know that I squared is equal to negative 1, so plus 15 times negative 1. So now you're going to have 8 plus 22i minus 15, because 15 times negative 1 is negative 15. So then you're just going to combine like terms some more. You're going to have negative 7 plus 22i. And that is your final answer. You cannot combine anymore. And that is your answer for this complex number. Now I want you to be able to see when this would occur and whenever you're doing a quadratic. It would occur if you ever had, when you were doing the quadratic formula or anything, mainly with the quadratic formula, if you had a negative number underneath your radical. Okay, I hope this helps. Thank you.